Welcome to this session. We are still continuing with the guide for UCE Mathematics. Now we are going to look at section B. In part 1, we've picked one item. We shall be doing two items. In part 1, now this time we have concentrated on item 3 about matrices and probability, and then item 6, which had taxation and then similarities and enlargement. So senior 2, senior 3 and senior 1. It's better to watch this video when you have where to note down some important things such that you understand everything. May not get everything in the head, but when you have written somewhere, you can easily go back and recall. If you've not subscribed, make sure that you subscribe, like, and channel. And for senior 3s, 2 and 1, we shall have our lessons during the holiday, but we shall be communicating via our platforms, especially WhatsApp, Group Math Connect, and also Students Globe. And then here we have item 3, and this is under section B. And here we have, it is all about data and probability, but and remember, under data and probability, it's all about presentation. So here we have a number about matrices and then probability. So here under matrices, it's all about arranging your information in rows and columns. And at least through those hints there, the hint there in rows and columns, and also stating the order or the dimension of matrix. So here in our task, it is seen there, clearly stating the order of the information that you have organized. And also when you what I also saw in this item for matrices, it wasn't hard, but also that the only technique that was thrown there, the only challenging part was here, changing now the order. They started with 12 bottles of soda, 15 bottles of juice, and then 20 bottles of water. And now, unfortunately, here, they started with 12 bottles of juice. So now it's possible that whoever maybe this number looked to be simple, but this part here, just changing the order, might have brought issues to senior 4s. But our advice is one, a senior 4, it would be better not to watch this video. It's now best video for senior 3s. Now, first of all here, I'm going to first start with a title, table showing items bought, items given to employees. It's better if I put it in the table. Now I'll have here Moses, then I'll come here and I have Sarah. Now here we have, let me have here bottles of soda, then I have bottles of juice, then I can have bottles of water. Maybe here Then I can write employees. First of all, I have Moses. Then I have here Sarah. Then these are the items. And again here, can allow me put here prices. So here you will come and you ask, how many bottles of soda did was Moses given? Moses here was given how many bottles of soda? 12. I put 12 there. Then how many bottles of juice was Moses given? 15. And then how many bottles of water was Moses given? 20. And then here, Sarah has been given 12 bottles of juice. 12. Don't just put here 12 and run. 12 bottles of juice, and then 18 bottles of soda, 18 here, and then here 15 bottles of water. Here 15. So how much is each bottle? Prices for each. Here we have how much is for each. Now here we shall come and we say the price of each bottle of soda, juice and water is 1,000, 2,000 and 500 respectively. So it means that each bottle of soda is for 1K, each bottle of juice is for 2,000 and each bottle of water is for 500. So we shall come and we say this is 1,000. Then here 3,000. Here we have 2,000. And then here we have 500. So now this is our table. It would be better for you to come and you extract the matrix. Remember, matrix is arrangement of numbers in rows and columns inside brackets, all put in brackets. So, but remember, this is under data probability. You should put there a title and come and say matrix for items. Then here come and say 12, 15, 20. Come and have here 18, 12, and then here 15. Now you come and you state this order. Even again here, matrix for prices. Here we have 1,000, then we have 2,000, and then here 500. So what is the order for this matrix? How many rows do I have? I have row 1 and then row 2. And then how many columns do I have? I have column 1, column 2, and then here column 3. These are the horizontal lines are rows, and then vertical lines are the columns. So we shall come and we say this is a 2 by 3 matrix. 2 by 3 matrix, and then this is 1 by 3 matrix. That is a 1 by 3 matrix. But now, after finishing that, you need also to be very careful. Maybe we can run to this. They are asking, now part A is done. Calculate the amount she she should expect from each worker. But if you look at this, rows are representing workers. And then here in the matrix for items, and then columns are representing items. Now for part B, it's all about multiplication of matrices. When you're multiplying, if items have made columns, then here we should have prices making rows. But unfortunately, here in my matrix, I would have organized it as a column matrix. But from the table, I never wanted to bring now issues. I've extracted it as a row matrix. But now here, maybe we can see it here. The matrix here is, first of all, for the two matrices to be multiplied, here if I have 12, I have 15, I have 20, then I have 18, I have 12, and then here I have 15. Now I cannot come and I multiply these matrices. Then I come and I say 1000, then I come and I say 2000, and then 500. I cannot multiply those two matrices. Reason: this is a 2 by 3, and then this one is a 1 by 3. But for two matrices to be compatible multiplication, here the number of columns in the first matrix and now you should come here and ask how many columns. Here we have 3. And then I have how many rows? I have 1 row. Now these matrices cannot be multiplied. At all I have matrix A and matrix B. If a matrix is a 2 by 3, now the number of rows in the first matrix, the number of columns in the first matrix should be same as number of rows in the second matrix. So these two matrices can be multiplied. Reason: the number of columns in the first matrix is same as the number of rows in the same matrix. So as long as you are organizing them to be multiplied, now the last value of the order on the first matrix should be same as the first value in the order for the second matrix, as you have arranged them for multiplication. So for this one, if you arrange it like this, you can't multiply them. So what are we going to do? We are going to come and arrange it in a good format. In a good format. Now here, this is a 2 by 3. So it means that this matrix should be 3 by 1. Because here I can have 1000, can have 2000, and then here I have 500. Now I can multiply those two matrices because the first column was representing soda, and this is the cost for soda. The second column was representing juice, and is representing now juice, and then if juice is for 2000, and then the last column was representing water, and each bottle is for 500. Now these two matrices now compatible for multiplication. So when we are multiplying those matrices, we multiply row by column. So come and say, but it's better you put there the title, finding amount expected from each worker. And now finding amount expected from each worker. Expected from each employee. So come and say 12 times 1000. Remember, we multiply row by column. So it is 12 times 1000, then plus 15 times 2000, then plus 20 times 500. And then here also that is done. 18 times 1,000 plus 12 times 2,000, then plus 15 times 500. Now, what do we get here? Make sure that these ones are the same. You see, I have 1,000, 1,000. Here I have 2,000, 2,000. And then here I have 500 and then 500. That shows that I've multiplied right. The moment you fail to get that, then just know that you've multiplied wrongly. So here, maybe I can first take off. Then we can proceed. So we shall get our answer as, here we shall get our answer as 12,000 plus 12,000 plus 30,000 30,000, then plus 10,000. And then here we shall have 18,000 plus 24,000 and then plus 7,500. When you add all that, you get the final answer as 52,000, 52,000, 52,000, and then here we get 49,500. So now here you can see that when you multiply this one, now the result matrix will be these ones. Now these ones are equal. Now we shall have a 2 by 1. But 2 by 1, a 2 represents rows in the first matrix. But what does each row represent? The purchases, okay, the items given for each person. And which person was coming first was Moses, and then Sarah second. So you come and give a conclusion. It means that this will be the amount of money that should be expected from Moses, and then this amount of money should be expected from Sarah. So you must give a conclusion that she should expect 52,000 and 2,000 and 49,500 from Moses and Sarah respectively. So you must give there a conclusion. So that's what you should do for senior series. Now also they asked another part about probability. And for the case of probability, it is all about they asked tossing similar coins. Now, first of all, I'll come here and I say table showing possible outcomes. When two coins are tossed. First of all, I'll come here and I say coin 2. Then I come here and I say, I can come here and I say coin 1. First of all, coin 1, coin 2, okay, coin 1 is expected to must have a head or a tail. And also coin 2 should have a head and a tail. But when I toss those two coins, I can get head for the first coin and also head for the second coin. At the same time, I can have head for the first coin and then tail for the second coin. Even here, I can have tail for the first coin and then head for the second coin. Then I can have tail for the first coin and then tail for the second coin. But now here they said that they wanted to send someone to go who will go to shop. And they said if now and they said that if at most one head, they say that if at most one head appears on top, then Moses will go to attend to the shop. And if no head appears on top, then Sarah will go to the shop. First of all, you come and ask yourself, what is the probability of at least one head? At least one head. But from this, you just come. At least one head means one head and above. This one has a head, this one has a head, and then this one also has a head. So here, in fact, here the sample space here is head, then I can have head, tail, then I can have tail, head, and then lastly, tail, tail. So those are the possible outcomes. And then total outcomes, here we have 4. But now, how many outcomes are having at least one head? There are 3. So we shall have 3 out of 4. If you want to express it as a percentage, now 3/4 times 100, and then we get 75%. And then come probability of no head. Probability of no head showing on top. It is only 1. Let me even circle it with red. Tail. So it means that we shall come here and we say it is 1 out of 4. And if I express it as a percentage, it's 1/4 times 100, and I get the answer as 25%. Now here the question is asking, determine the probability with which the worker with the highest chance will be selected. Now, the probability with which the worker with the highest is Moses has the highest chance. Moses has the highest chance of 75% or 3/4. And he will go attend the shop. So that was all about probability. At least don't expect in like senior threes, at least if this one came, at least would you also take this direction? But these are the responses for that particular scenario. If you have not subscribed, please make sure that you subscribe, like, and follow. And also, I remind you that we shall be having our holiday lessons. Please endeavor to be part of them, such that next year we want to see S being got by every person in our Math Connect. So here our scenario reads: a head teacher of a school with 500 students has been receiving reports of some students missing porridge in the morning. In defense, the caterer claims that the students are many and use big cups, yet the container in which the caterer keeps porridge to be served is small. So the container has the surface area of 96,000 square centimeters and volume of 128,000 cubic centimeters. The caterer has requested the head teacher to buy a similar larger container of surface area 150,000 square centimeters so that the volume of porridge to be served to each student increases when the larger container is filled to capacity. As a way of improving the services at the kitchen, the head teacher has employed another cook who will earn a gross monthly income of this income includes transport allowance of 15,500 shillings, housing allowance of 81,150, lunch allowance, which is 10% of gross monthly income, and then utilities allowance of 35,500. And the cook is supposed to pay the income tax according to the structure in the table given, but all allowances are free of tax. So this is the table from this up to this, and then the cook is interested in knowing his net income. So determine the quantity of porridge in liters so that will be served to each of 500 students if the caterer gets a larger container and each student is to receive the same quantity. And then the last part is to compute the net income for the cook. Now, when you look at item 6, it required a learner to be knowing very well the topic of similarities and enlargements. So here I'm seeing the first part needs similarities and enlargement, but specifically linear scale factor, volume scale factor, and then area scale factor. And then the second part is all about business mathematics, that the one we look at in senior 3 term 2. And now they brought taxation. So you need to have mastered finding taxable income, at the same time finding income tax, and then lastly net income, which is also known as take home. So now we can start with the part A about similar figures. So the scenario is here, 500 students. But here the small container has the surface area of this one, and this volume of that. Then the caterer has requested the head teacher to buy similar larger container of surface area, this one, so that the volume of porridge to be served to each student increases when the larger container is filled to capacity. Determine the quantity of porridge in liters that will be served to each of 500 students if the caterer gets the larger container and each student is to receive the same quantity. So here, when you see area and area for two shapes, then this is all about similar figures. Remember us covering similarities and enlargement. Now here we say that linear scale factor is equal to the ratio of corresponding sides. But now that I don't have sides for the two containers, again you'll come and say, what about area scale factor? Area scale factor is equal to linear scale factor, then bracket squared. Then volume scale factor is equal to linear scale factor bracket cubed. And now for this scenario, you come and see, what have I been given? I'm seeing here area for small and then here area for big. And to find also volume scale factor, you can compare volumes. So we shall come here and we say volume of a bigger container divided by volume of a small container is equal to linear scale factor cubed. Similarly, area of a big container divided by area of a small container is equal to linear scale factor, then squared. So for this case, now that I have area and area, I have two areas, so it can be easier for me to find the area scale factor. So we shall come and we say area of big container, bigger container divided by area of a small container is equal to linear scale factor bracket squared. But from the scenario, the surface area of a bigger container is 150,000 divided by area of a small container which is 96, then here 000 is equal to linear scale factor, then bracket squared. So here if you cancel those zeros, you get 150 divided by 96 is equal to linear scale factor bracket squared. So if you see a square, now introduce the square root symbol on both sides. And then here we shall have linear scale factor is equal to 1.25 as linear scale factor. But now that I have linear scale factor, now I can be able to get the volume. So you'll come here and you say that volume scale factor is equal to linear scale factor, then here cubed. Now you'll come and ask yourself, how can I get volume scale factor? You compare the volumes of the two similar figures. Come and I say volume of big container divided by volume of a small container is equal to linear scale factor, then here cubed. But I have volume for small container, that is 128,000, and I don't have volume of a larger container. So here we shall have volume big divided by 128,000 is equal to a linear scale factor cubed, which is 1.25, then here cubed. Then you shall have, if you reach here, you cross multiply, and then here we shall have volume big is equal to 128,000 times 1.25, then here cubed. And I'm seeing my answer as 250,000. But remember now, volume here is in cubic centimeters. But they had asked us to find the quantity of porridge in liters. So you'll come here and you say that capacity is equal to volume divided by 1,000, and it should be in liters. So here we shall come and we say that this will be capacity. So capacity of larger container will be 25,000 divided by 1,000. Then we shall have capacity or volume as 250 liters. So this is the capacity that will be, this will be the capacity of larger container. Capacity of larger container. But now they are asking, if the capacity of this larger container is 250 liters, how much porridge will each student get? So here we shall say quantity got by each student. Got by each student. So we shall have 250 divided by 500. Then here we shall have the answer as 0.5 liters. So after reaching there, remember you have to give a conclusion. So you will say that each student will receive 0.5 liters. That's how we had to respond to this item, which required using area scale factor at the same time volume scale factor, which we learned under the topic of similarities and enlargement in senior 2. So here is the second part of item 6 about business mathematics, which we learned in senior 3 term 2. Now here they brought taxation. Now here we want to look at the key information in this. I'm seeing gross monthly income, this. So allow me right here, gross income, that is 853,500. And then I have allowances. Remember I have transport allowance. Yes, it is here. Then I have also housing allowance of this. And again I have lunch allowance, but allow me lunch allowance. Allowance is 10% of gross income. So here it is 10 out of 100, then times our gross income. Remember it is 853,500. So here the answer that we get here as lunch allowance is 85350 as the answer, as the lunch allowance. And these are the tax slabs. Here we have taxable income, then we have rate. So we shall come here and we say that after having that, the first step is you finding the allowances. Just before running to find the income tax, remember you have to, here the question is asking us to find the net income for the cook. But remember, net income, here we have net income is equal to gross income minus income tax minus income tax. But before running to find the income tax, you should be able to first find the allowances. And now we shall come here and we ask ourselves, can we find the allowances? So here I'll come and I say, finding allowances, allow me have here lunch, and here lunch, we have 8, 5, 3, 5, 0. Then I have utilities, and utilities I have 3, 5, 500. And then I have transport, I have transport, I have 1, 1, 5, and then 500. And then I have also housing, and housing allowance is 81, then 150. So if you add all this, you get the total allowance of 317 and then 500 as the total allowance. So from that, you can come here and you find the taxable income. Maybe allow me put it here. So we shall come here and we say taxable income is equal to gross income minus allowances. So we shall have gross income of 853 and 500 minus allowances, which are totaling to 317 500. And then we have the taxable income of 536,000 as the taxable income. So you come here on your table, the tax slabs. You ask yourself, income bands here, where does this taxable income follow? You see here, we are having 53. So instead of this one here that I've circled, just put there my taxable income, because you cannot tax more than what you have. We tax what is available. So here we'll come and we say 536 and then 00. Senior threes, this is very important for you. Now, after finishing that, allow me take off this. Now I'll need to come and find the income tax. Come here and I find the income tax. I'll come and I say taxable income. Come and I say here rate, and then here income tax. Number 1, from 0 to 105,000, it is free. So you come and you ask, free means they don't tax that amount. So the first taxable income is 105, then here 3 zeros. The rate is 0. And remember here the rate is in percentage. So 0 out of 100 times this, we shall remain with 0. Then also here, have from 105,001 to 250. Please don't always subtract this one. It's just a place value holder. You always replace it with a 0. So get 250 minus 105,000, but always avoid getting an ugly answer as 99999. No, replace that one as a 0. So when I subtract 250,000 minus, and then I subtract 250 minus 105,000, we shall get 145,000. So you shall have 145,000. And the rate here is 13. Now here you'll come and you ask yourself, how do I get the income tax? You'll say 13 out of 100, then times 145,000. And here the answer that you'll get will be 18850. Then here we have the second band from 350, from 250 to 350. There is now 100,000. Get 350 minus 250. These ones you get 350 minus 250. So the answer is 100,000. And here the rate now is 20%. So you come here and you say 20 out of 100, then times 100,000. And here the answer that we are getting will be 20,000. Then also you'll proceed and ask yourself again, from 350 to 450, how much is that? Still, it is 100,000. Because 450 minus 350, we get 100, and the rate is 30. So here we'll come and you say that 30 out of 100, then times still 100,000. So the answer that we are getting here will be 30,000. So far, how much have we taxed? If you add all this, we get 450,000. Yet, what you need to tax should be 536,000. So keep on monitoring taxable income. Taxable income should be totaling to the amount of money that you have taxed should be totaling to taxable income. So from 450, 536,000, how much is there? Subtract. Come here and get 536,000, then minus 450,000, and the answer that you get will be 86,000. So it's what you are going to put here, 86,000. And the rate here is 40. So come here and you say 40 out of 100, then times 40 out of 100 times 86,000. And the answer that you get will be 34400. So this is the income tax. That is the income tax. After that, it's better you come now and you find the total income tax. You add all this under income tax and see what you'll get. If you add all this, you get the total of income tax as 103 and 250 shillings. You get 103, 250 shillings. So that is the income tax. But remember, they had not asked us to find the income tax. So you're going to allow me to take off this one, taxable income, now that we have seen it. And then we've come here and we find the net income. So we shall come here and we say that net income is equal to gross income. Net income is the same as take home minus income tax. And so here we shall have gross income, which is 853, then 500 minus the net income, which is minus the income tax, minus the income tax. Subscribe, like, and share for more videos, and make sure that you tap on that notification button so that you can get any video that we may upload on our channel Math Connect. And also you can contact us on our WhatsApp number. Also send us our email. Thank you so much for watching. Meet in the next session.